Part 3 of our Parabola series. We have two examples here on the screen. Our job is to find the focus and the directrix of each, and we'll also draw a quick sketch. And to do that, of course, the main idea here is to find the p-value and then go from there. So in this case, this one on the left here, letter A, is pretty easy. This has a vertex at 0, 0. I know that because there are no parentheses, there's no H or K. This doesn't shift left, right, up, or down. It just has a vertex at the origin. So that is our vertex. And from there, I can see that it definitely opens up or down. And I know that because the squared term is the x and the linear term is the y. So that means that it's going to open either up or down. And to determine which one it is, of course, you just look at the A value. The A value here is positive. So that means we're going to open up. So I know that this parabola is opening up. And our job, of course, is to find the exact value, the exact coordinates of the focus, and the exact equation of the directrix. To do that, we need the p-value. So here we go. We have a pretty simple task. We've been doing this 4py is equal to x squared process. And in this case, we need to transform our equation, letter A, into that format. So let's get x squared by itself. To multiply, or to get x squared by itself, we want to get rid of 3/5, which means we're going to multiply by 5/3. So those are equivalent expressions. The bottom one happens to be in the right format. So now we can use that little correspondence there to find our p-value. So 4p is equal to 5/3. Alright, divide everything by 4. When we divide everything by 4, you simply 5/3 divided by 4. Well, that's the same as multiplying by 1/4. So our p-value is 5/12. 5/12. Now, that p-value, of course, as I mentioned many times before, is the distance between the vertex and the focus. So let's say this right here is our focus. That p-value is that distance right there, 5/12. It's a little less than a half of a unit. So that means that our focus, and remember, we already knew that this graph was opening up because of our knowledge of the sort of the general format of the equation. That means our focus is 0, 5/12. And that means our directrix is exactly the same distance away from the vertex in the opposite direction. Remember, the directrix, as we mentioned before, is an imaginary sort of boundary for all those points on the parabola to guide where it goes. If you remember back to the actual definition of parabola, every point on the parabola is equidistant from the focus and the directrix. That's the general rule. So if this is a certain number, this is a certain number as well. And that's true of every single point on the parabola. So that has, of course, the directrix, of course, has an equation. It's a line, so it's y equals negative 5/12. So there you go. There's your focus and your directrix. Over here to your right, letter B. Find the focus and directrix of this one. This one's a little bit more complicated. I want to sort of analyze what kind of parabola it's going to be first. And by looking at this one, I can see that it's definitely going to be opening either left or right, because the y term is squared and the x term is linear. And from there, I can see that since that's my A term in my vertex form, my A term is positive, so this thing is going to be opening to the right. So let's look at the vertex first. The vertex of this parabola, this sideways opening parabola, is given by this format. We have x equals a times y minus k, or excuse me, y minus, yeah, that's k, quantity squared plus h. So this is actually our h term, and this is our k term. So the h term comes first, that's positive 3, and the k term comes second. If it's negative here in the parentheses, it's positive over here. So my vertex is actually at positive 3, comma 1. So I'll draw that right now. There's my vertex. And this is opening to the right. So that's generally what my parabola is going to look like. So if I know anything here, I have a general idea that my focus has to be in here, which means my directrix should be equidistant over here. And I need to find those exact values, the exact coordinates of the focus and the exact equation of the directrix. So let's give it a shot here. We have, let's see, we have some work to do. I have an equation that we just need to find the p-value. So what I might do is just get rid of all this. I'm just going to erase all this stuff to give myself some more room and set up my basic formula for my p-value. That's the key here. Remember, the p-value is the distance from the vertex to the focus and from the vertex to the directrix. And in this case, the general value is going to be 4p x is equal to y squared. That's how we find our p-value. I'm using that format here because, again, it's y squared. So let's get this whole y squared by itself. I know it's y minus 1 quantity, but that's alright. Let's get it by itself. So I'm going to go x minus 3. I'm going to move that positive 3 over to the left by subtraction. And I'm going to get rid of this 4. I want to make that a positive 1, so I'm going to multiply everything by 1/4. So it's 1/4 times quantity x minus 3 is equal to quantity y minus 1 squared. And that, believe it or not, is actually in the right format. These two things right here are essentially in the same format right there. So what we want to do is look at the 4p and the 1/4 and just set them equal to each other. Again, it doesn't matter that we have parentheses, right? It's all sort of the general same idea. So let's go ahead and set 4p equal to 1/4. If 4p is equal to 1/4, we're going to divide by 4 and get 1 over 16 as our p-value. It's important. That's the distance that the vertex is from the focus. So if our vertex is at 3, 1, our focus is over here somewhere, moving to the right 1 over 16. So we need to figure out from, let me get rid of this for a second. We need to figure out from the vertex going right 1 over 16 units. Well, the x coordinate tells us right and left, so we need to simply say what's 3 plus 1 over 16. Well, convert that. Common denominators. So our focus resides at 49 over 16. So I'm going to put that maybe in a green. Our focus resides at 49 over 16, and it's still on the same sort of level, same vertical level as the vertex. So those are the coordinates of our focus. Our directrix will go in the other direction, and I'll put that in orange. Our directrix goes left of the vertex 1 over 16 units, and that's going to be a horizontal line and when the line's horizontal, your equation's x equals something. Well, that x equals something is going to be, well, think about where the vertex is. It's at x equals 3. So we basically just need to go 3 minus 1 over 16. So that's 48 over 16 minus 1 over 16 is 47 over 16. So those are your two answers there. Your directrix is x equals 47 over 16. Your focus is 49 over 16, comma 1. And again, this would be a parabola facing right, just like that. The focus is sort of tucked inside of that parabola. Cool. Moving on. Write the equation of this parabola when given only the graph. To do that, we need to sort of think about where the vertex is. Make that a little bit smaller. The vertex, of course, is down here. That's our vertex. The coordinates of that vertex seem to be -5, comma -1. And from there, our directrix will be below that, and our focus will be above that. So to do this, it's kind of like one of the problems I think in part 1, where we have a parabola that definitely goes through another point that we can see. It goes through this point, -3, comma 0. So let's set up our vertex form, which is y is equal to a times x minus h quantity squared plus k. The vertex we already said is -5, comma -1, so that's +5 and -1. And the x and the y we're going to take from the point that we saw that the actual parabola goes through. Our task here is to find the a value. So we're calculating the a value, and we're just going to solve for a. This is 2 squared minus 1, so we're going to move the 1 over. So a is equal to 1 over 4. Now that's important because now we can write our equation, the equation of the parabola, and we didn't really start off with specific information about the vertex or the focus or the directrix or anything. We basically just picked 2 points, the vertex and any other point on the graph, and went from there. So if you wanted to, and that was the sort of the crux of this problem, you only needed to find the equation, but if you were asked to find the focus, your next task would be to find the p-value. So let's go through that really quickly. This is an x squared parabola that opens up. The a value is positive, so it opens up. So we're looking to do this. We're looking to find the p-value based on that format. So we essentially just need to get this whole thing right here by itself on the right side. And to do that, I'm going to just simply add 1 to both sides and multiply both sides by 4. So that'll give us quantity x plus 5 squared on the right is equal to this thing on the left. And again, it doesn't matter that we have the parentheses here. 4p is equal to 4, which is kind of cool because p is equal to 1. So if p is equal to 1, then our focus is 1 above the vertex. So the focus is right here, and the directrix is 1 below that. I'll put it in green. The directrix would be down here. So that's kind of a cool thing. Now if you're at home and you're on a computer, you can check out this really cool website that I'm going to show you right now to kind of check some of these answers. Right, your focus we said was -5, comma 0, and your directrix would be y is equal to -2. To check some of that work, what I want you to do is check out this website. We're going to go to wolframalpha.com. I'm going to type in that parabola right there, 1/4 quantity x plus 5 squared minus 1. So I'm just going to type it in here. Y is equal to 1/4. I'll type it in as a decimal. Quantity x plus, what was it, plus 5. Quantity squared. And it was -1. And I'm going to ask for the focus. We'll see what comes up here. This is one of those great search engines that not a lot of people necessarily know about. You can see right here that the result of this query is -5, 0, which is precisely what we had in red right there. And if you scroll down, it tells you what kind of geometric figure it is. It gives you a visual representation. That's the graph. It gives you the vertex. It gives you the directrix as well, which is the equation y equals -2. And if you typed in anything else, you can probably find out, the axis of symmetry, or, if we type the directrix in, let's see what happens. It's computing, it's figuring out for us what we're looking for. And there you go. Y equals -2. So it works out nicely for us if you want to use this search engine. You can also use this Desmos.com calculator. It's kind of a cool thing. You can launch the calculator there, and you can graph stuff in here. So it's kind of nice. You have all sorts of great options here to graph stuff, and you can see right there, that's not exactly what I wanted, but that's more like it. Well, no, it's not. So if we type that in, we can see that this is the same thing. Y equals 1/4 times quantity x plus 5 squared minus 1. And you can go over here and you can sort of hover over these points and see that -5, -1 is in fact the vertex. Up here, -3, 0 is a point. Over here, -7, 0 is a point. You could have used that as well in our process. But anyway, there's some cool websites that you might want to check out. Let's try this one. Might be a good idea to try this one on your own, see if you can get it. It's a sideways parabola. And so pause this right now, give it a shot, see if you can write the equation of this parabola when given only this graph. So the first thing I'm going to do is I'm going to identify the vertex. The vertex is right here, and that has coordinates of 1, 2. And this is a sideways parabola, so it's going to be of this format. It's going to be x equals quantity y minus k squared plus h. And this is h and k. So let's just plug this stuff in, see if we can make some sense of this. K is 2, so I'll put that in there, and H is 1. A point that's definitely on this graph is, looks like 0, 1, definitely resides on that graph. So let's plug that in for our x and our y. So 0 is equal to a times the quantity of 1 minus 2 squared plus 1. That's -1, quantity squared plus 1. 0 is equal to a plus 1, so a looks like -1. If a is -1, that means we're simply going to replace a with -1. So I'll just put negative quantity, oh, let me rewrite that, that's an x instead. X is equal to negative times the quantity y minus 2 squared plus 1. That's the equation of this graph. And again, you can from there find your p-value, which will give you your focus and of course your directrix. And okay, sometimes next up here, sometimes you'll be asked to transform these sort of more traditional looking parabolas into vertex form. And this is kind of an Algebra 2 exercise, but we need to get this thing into sort of the right format for finding vertex or vertices. So it's basically getting them into this format. To do that, we need to complete the square. Completing the square. And what that means is we take these two terms, the squared term and the linear term, and I'm just going to take the -2 out of them. So I get x squared plus, let's see, if I divide -36 by -2, I get 18. I'm going to leave a little spot, and I'm going to write -61 over here. The rule is pretty simple. You take this thing right here, this is kind of like your b term, cut it in half, 18 over 2 is 9, and then square it. 9 squared is 81. You're just going to add that right there. But in order to sort of account for that huge addition, you need to make sure that you add something over here as well to sort of counterbalance that. So -2 times 81 is -162. So we essentially, by putting a little positive 81 there, in terms of the equality of this right-hand expression, the value of the right-hand expression changed by -162. So I need to counterbalance that by adding 162 at the end to make sure that the right-hand side of my equation hasn't really changed in terms of its value. Alright, so let's simplify that. We have y is equal to -2 times the quantity x squared plus 18x plus 81. And this is nice and neat. That's just a +1. And the reason that this is kind of cool for us is because now all of a sudden we have, if we were trying to like FOIL this or figure out the factors of this quadratic, it's actually pretty easy. You can see that it's x plus 9 times x plus 9, which we can rewrite into this format. So there's our vertex form. You can easily pull your vertex out of there, -9, comma, +1. And from here, if you were asked to, you can find the p-value, which will give you the focus and the directrix, and you can graph it nice and easily. And how about this one right here? We have a task to find the vertex form of this thing. So let's see, I can definitely see that it's x squared, so it's going to be, we want to get the y by itself. So isolate the y term. So let's leave that where it is and move everything else sort of over to the left. So we have -y on the right, and then -4x squared plus 16x minus 15 over here on the left. I don't really want -y, I want +y. So I'm going to say +y is equal to 4x squared minus 16x plus 15. And then I'm simply just going to kind of rewrite that so my y is on the left. So I just move that all the way over. Okay. So again, this is like an Algebra 2 or Algebra 1 where you can type this into a calculator, graph it, and figure out the axis of symmetry and all that stuff, right? But for right now, let's actually transform this into vertex form. So let's take the first two terms, and I'm going to simply remove a 4. Let's remove a 4, leaving us with x squared minus 4x. We're going to leave a space, plus 15. So again, the rule here is we're going to divide this in half. So -4 over 2 is -2. And then we're going to square that. -2 squared is +4. I'm going to add that right here. To account for that, I want to think about the fact that it's 4 times 4, if we sort of distribute that back in. So that's a plus 16. If we added 16, we need to counterbalance that by subtracting 16. So we have up here, y is equal to 4 times this quantity, that trinomial. 15 minus 16 is minus 1. And again, let's transform this into x minus 2 quantity squared. All right, if you take x minus 2 and multiply it by itself, you get first times first is x squared, outside, inside, and last. So you definitely get that quadratic. And there's your vertex form. You can pull your vertex out really easily. Your vertex then would be positive 2, negative 1. From there, if you wanted to, you can find your p-value, which gives you focus and directrix. So there you go. Hopefully that helped you. You know what I like to do at the end of all this stuff, this is the last installment in our Parabola series. I like to kind of organize my thoughts, and you know, if you want to pause this and kind of write all this stuff down, this is sort of the summary of the notes that you need for this stuff. It gives you the vertex forms, the p-value equations, the traditional forms of the parabolas in vertex form. It gives you the forms when the vertex is not at the origin, and this right here is important too. The p-value is a distance that the vertex is from the focus and the directrix. So that wraps up part 3 of our Parabola series. Moving forward, we're going to touch on what an ellipse is and a hyperbola as well. So thanks for watching.